All right, let's start the topic 10 review. You'll notice this time we have a little bit of key information, primarily from 10.1 and 10.2 at the bottom here. This is just so we can reference it as we go. These are things you're going to want to know for the test as well. So when I talk about them, you have them there ready to go for you. Our number one question is, what is the length of arc HJ? That means I'm trying to find the length of this arc right here. And the first thing I want to do is ask myself, is this in degrees or radians? This is in radians. I don't have a degree symbol. For now, that's our number one way to determine which method we're going to use. This is in radians, so you can see the arc length in radians is S is equal to theta times R. Theta is our central angle, so that's pi thirds. And R is our radius, which is 6. When we multiply these together, we get 6 pi thirds, which simplifies to 2 pi. All right, for number 2, we can see this one's clearly in degrees because it gives us a central angle of 72 degrees. And what we're going to do now is go down the bottom and reference this if we haven't memorized it yet, but the arc length when we are looking at degrees is the arc length is equal to the central angle divided by 360 times 2 pi r. This is our central angle, and this 1 is our radius, so we can make our substitutions there. This is going to give me 72 over 360 times 2 pi, and r is 1. 2 times 1 is still 2, and 72 times 2 is 144 over 360. As I say in class, as I say every time we do this, is asking for it expressed in terms of pi. Even if it wasn't, if I still had to multiply this pi through, I don't do that until the very end, so just drop the pi down and we have our answer. Now the reason, if you're not in my class or you missed the class or you kind of checked out every time I've said this, if I'm using pi, or if I'm multiplying by pi, pi is an irrational number, so we're going to always end up with an approximation, and we know we never round until the very end, so we do have to save multiplying by pi to the very end. What we have left to do is to simplify this, or make it in its simplest form. And I'm looking for my TI-30XAN, trying to stall at the same time, and I don't see it. So we're just going to have to do this the old-fashioned way. These are both divisible by 12. 12 times 12 is 144. And 60 times 12 is 30. That's still further divisible by 6 to be 2/5 pi. That definitely isn't going anywhere. Those are both prime numbers. So I'll have a final answer of 2/5 pi for this one. All right, here we go for number 3. Write an expression in terms of pi that represents the shaded part of circle with center in. So for that, I'm going to look at box number 3 on my screen. The area of a sector is n over 360. That's the part of the circle that we want, times the entire area. So we're just looking at a percentage of the area, like I've said in class. Here, n is equal to, well, this time it's not 75. That's not the shaded area. That is this angle here, or our major arc is what we're looking at. And to find that measurement, we're going to do 360 minus 75, and that's going to give me 285, and I have a radius of x. So I can start plugging things in here. I'm going to have 285 over 360 times pi times x squared. Now they want it in terms of pi, so I can go ahead and drop this down to my final answer. And my radius is a variable, so I'm going to drop that down because there's no simplification that I can do there. And I'm not going to bring it up here because it's going to not be accounted for when I simplify this fraction. 285 and 360 are both divisible by 15. So let's see what that brings it down to. This is going to give me 19 over, and now I just need to know, there we go, what 360 divided by 15 is. That's 24. We definitely can't simplify that anymore, so our final answer is 19 over 24. Missed part of my answer in my circling. Times pi times x squared. All right, you'll notice we skipped a few questions. Anything that says select all that apply has the check boxes for yes or no, drag and drop are all being deleted off of your test. That's why you're going to be taking your test in two different forms, or I'll just end up combining them now that I'm saying that. And there will be no select all that apply, no drag and drop, no drop down menus. Every time we do those, we end up discussing them and we end up dropping them from the score anyways. So let's not have them. Let's give you a full test that will count for every question. With that being said, let's look at number 7. Given the circle with center D and the fact that line segment EF is congruent to line segment FG, what is the measure of arc EF? So the question is, what is this guy right here? And to do that, I need to look at some of the other information they've given me. I know that EF is congruent to FG. So let me backtrack and just make this a congruency mark. This is EF, and I've now shown that it's congruent to FG. So I just have to see, is there anything I know about this that will save us or give us a way to answer this? Well, let me change colors on this one. And let's go with a nice green. Let's talk about, what do we know about line segment ED? What do we know about line segment FD? And what do we know about line segment GD? Well, each one of these is a radii, or is a radius of the circle, and all radii are congruent. So I can say this for sure. Or this. And now I can look at these two triangles and see if that helps me at all. Well, here, DF is going to be congruent to DF in both triangles. Here, DG and DE are congruent. And it was given that EF and FG are congruent. So these are congruent triangles by, I'll put congruency by side, side, side. If the triangles are congruent, their angles are congruent. Since this is 68 degrees, this is 68 degrees. I know we did a bit more, we drug it out more in class, but that was really to cement all the topic 10 concepts in your mind. But once we learned them and we're being tested on them, if you guys want to make connections like we just did back to topic 3, it's a really good idea because it helps you practice and show mastery of previous concepts. All right, number 9, 10, and 11 require this diagram. Looks like a doozy. So let's see what we're given. We're given KPH is 100. So I'm going to go ahead and mark from K to P to H. And just make a note that that's 100 degrees. HK, that's this line here. And L, N are congruent, as well as JK and L, M. Okay, that's pretty easy to see. What I'm going to do is not keep this on here. This looks like it's going to be more than it needs to be. And by more than it needs to be is it just looks messy now. If I'm going to be doing a lot of work with these, the way I'm going to keep this in my mind on where these go is this is simply a little, in my mind, that's reflected across this line. And we might have to rotate a little bit, but we would see J would map to M, K would map to L, H would map to N, and my congruency marks for these two would map up, as well as these would be 100. So I'm going to go ahead and clear all this so I have more room to look at the picture and work on it. It wants to know which angle is congruent to JPH. So J to P to H is this part right here. Oh, don't have my line tool back on yet. So JPH is here. And what I'm going to do then is say, if I were to reflect it over that line again, where would I land? This would come across the line and be right here. So my answer to this would be MPN. For this one, if the measure of arc LM, be careful when you read this. When I just read this a second ago, like, before I hit start record, I kept reading this as the angle MLM, and I kept saying that's just going to be a line because there's M and M, but that is the measure of arc LM. And it's saying if that arc is, how many degrees? 60. What is the measure of arc JH? Now that is all the way over here now. And we need to figure out what in the world are we going to do? How are those related? How are we going to do that? Again, go back to topic 3. Use your reflections. Use that trick I showed, and you'll see that this will map on to here. If we know this is 60, then this is 60. And we need to find this. And we're going to ask ourselves, how do we do it? Well, in our given, we know this central angle is 100 degrees. And notice I said central angle, and if you look at our central angle definition, that's any angle that's formed by two radii. KP and HP are radii, so we have a central angle. And we know that the arc measure is equal to the central angle's measure. So this is just going to be the 60 plus the x have to equal 100. And this is going to imply that x is 40. And since x represents JH, I had a moment of panic when I said LM because that wouldn't be the right answer. This is the measure of JH. And then it just says which segment is congruent to MN. Again, stick with the whole idea of going back to topic 3. I'm going to go ahead and find MN on here. That's this little one right here. And I'm going to imagine that if I were to flip this or rotate it so that they mapped onto each other, this would come to JH. That's like a J and a B had a son or daughter. This would be line segment JH for that one. All right, we finally have something a little bit different. I'm going to tell you now. We're going to need the Pythagorean Theorem. Told you in class, just tell you one more time in this video. Let's first identify what it's asking us to do. For number 12, it says, what is SR? So let's see. SR is going to be this chord right here. And since the answer chord is not an option, it's actually asking us what is the length of line segment SR. And to answer that, we need to know something about this right here. And this is a multi-piece puzzle where you have to apply pretty much every theorem we knew. And to get from here to here, it's going to be a lot to think about. So one thing that we're fortunate is the way that they've presented the information or our givens is we can work in a top-down manner to get to that answer. For PQ to be bisected by this line segment, this would have to hit it at 90 degrees. So this would be 21 here and 21 here. For this to hit PQ at 90 degrees, and this to be 90 degrees, they have to be the same length. So now we know that these markers indicate both of these would be 20. The only mistake here is I didn't increase my tick mark. They're not equal to the bisected pieces of PQ. They are different. Now that we know all of that, if this is congruent to this, these two, and both of them hit their respective chords at 90 degrees, then PQ and SR are equal. And since both of these are equal, our central from T to our chords, since those are equal and bisected, these are also equal. So this is 21 and 21. And since it wants the full length of SR, we're going to have a final answer of 42 on this one. Let me hit erase and let's look at the next question. What is the radius of circle with sensor T? So remember when we have a radius, I'm not sure how this shows up when I'm recording. You see, nope, you can't. That's interesting. Let me see if this shows up. Not until I'm done drawing. Okay. When it asks for a radius, that's any line, excuse me, that starts at the center and ends on the circumference. And usually I guess you could see my pen moving. So let's do that too. If I start at T, I can pick from T to anywhere on here. Every line that's not actually showing up, for some reason it doesn't show up if I'm actually committing to the line. Any motion that would take me from the center to the circumference is a radius. And if I want to know what the radius is, I can then say, well, if I know that this piece is 20 and it meets at 90 degrees with this side of PQ, I can use the Pythagorean Theorem to solve for it. And the nice thing is, since I can start at the center and go to here, it's literally asking me what is the length of that purple line. And to find that, I'm just going to do a squared plus b squared equals c squared. A is going to be 20, B is going to be 21, and C is what we're looking for. This is 400, and if this is 400, the next number squared is just taking that number plus the number before it and adding them together, plus that would be 441. If that's confusing, put a thing in the comments if you'd like to know in more detail what I meant by that, or how I knew that was going to be 441 without a calculator, or actually having committed 21 squared to memory. If I add these together, I get 881, 841. I would imagine at this point we're going to have a few questions about whether or not I was right, or asking for validity there, since I just added 400 and 441 and got 881. Now I need to pull up my calculator. And I need to know what is the square root of 841. I need to get rid of this. Be able to press a button here. And I get a nice 29. So maybe your doubt in me fades as you see that what we end up with is option. So yeah, it's not 881, it's 841. And the square root of that is 29, for a radius of 29 in this circle. All right, for the first time on the test, we're moving from central angles to inscribed angles. Really quick, I'm just going to go ahead and draw a central angle so we can see the difference. Notice the vertex here is at the center of the triangle, which is why we call it a central angle. Whereas for our inscribed angle, the vertex is on the circumference and its endpoints are on the circumference as well. GF and FH are radii. GK and KJ are chords. So there's another difference there. If I want to go from the angle measure to the arc measure, that is generated by my endpoints. So that means to go from G to H to J, I take this number and multiply it by 2. So I'd say 2 times 81. That's going to be 162. So the measure of arc GHJ is 162. Now this is asking for what is the measure of angle HJK. So let's clear off this and see if we can use what I just showed you to come up with an answer for that one. Clear my drawing. Let's go back in with the red and let's highlight the measure. What's the measure of angle? H, J, K. So start at H, go to J, go to K. So H, J, K is this one. And this one's actually a little bit easier than what they just gave us because we want to know, if we know this arc measure, we can divide it by 2 and it'll give us this angle right here. So what I'm saying is 80 plus 84 divided by 2 is going to be my answer for this question. And I already know that it's going to have to end in a 1, so let's do a prediction here. The reason I know it has to end in a 1 is because 0 plus 2 is 2. 2 divided by 2 is 1. This is going to give me 162 divided by 2. And this is, in fact, 81 degrees. Now it wants to know what is the measure of arc HJ. So let's clear this off because that's not going to be too relevant. Nothing here is going to help us. Let's retrace. So arc HJ is created right here. But I don't have an inscribed angle. I don't have a central angle, right, to tell me what that measure could possibly be. I have to use some other information here. I can see that I have a chord that ends at J. And I don't have a chord that ends at H, like I just said would help me, but I do have one that creates an inscribed angle with G. What's nice about that is, since I know this angle, if I take that number and double it, I can use the arc version of the segment addition postulate. It's called the Arc Addition Postulate to solve for this missing part right here. But before I do that, I have to know what the whole arc equals. So the measure of arc GHJ is equal to 2 times the angle GKJ. So I have 2 times 81, which is again 162. So I guess there was a little bit of relevance there. So if the whole thing is 162, and I know from here to here is 84, I can subtract 84, and what I'm left with will be X. So I know this answer is going to have to end in an 8 because 2 minus 4, or the only way to get 4 up to a 2 is to add 8, carry the 1. This is going to be 78, but let's use a calculator to verify it. 162 minus 84 is in fact 78, and that's how we knock out this one. All right, let's get into why we call geometry a reading, writing, and reasoning class more than it focuses on math in the standard way that you thought about it when you walked in the room day 1. Pretty much all of your education up into this part has either been elementary geometry, if you want to be generous in learning shapes and stuff like that. But primarily it's been arithmetic into algebra, and now you're into geometry, and you really are going to use a lot of this when you get to higher level math. It's just a nice little interruption in your algebra progression, but we still need this to help us develop our reasoning and at the same time further develop our reading skills. And what I mean by developing our reading skills here, when we only have 7 words and some of them are just symbols on the screen right now, is that can I look at a diagram and put it into plain English what I'm seeing, and then look at or delve deeper into the way that I've explained this in English to see if I can start deciphering clues, finding clues, and moving on. Of course, my instinct here, especially when I first learned this, was to look at this and go, where's the not enough information on this one? So before I even start talking about anything, we have a diagram that has a chord, 2 secant lines running through it. We have an arc measure of 102 degrees, and we have an angle marked 1. We don't have a lot of information here. The question's asking in the circle with sensor Q, What is the measure of angle 1? Oh, then this needs to be changed to a P there, Savas. This is center P. There's no Q on the diagram, so let's just assume that that was an error that we can correct to be able to answer this question. So let's talk about some of the things we see here. Like I said, we have two lines running through the circle. Don't really have a lot of information there. We have a chord that passes through the center of the circle, and then we have a circle. Well, that chord passing through the center of a circle has a special name. And without that special, well, knowing that special name might trigger or spark an, oh yeah, that's right, moment. We know it's a chord because it has its end point and its beginning point on the circumference, and it passes through the center. A chord that passes through the center has a special name, and that is the diameter. What's special about the diameter is it cuts a circle in half. That means I can figure out the measure of the arcs by dividing by 2. And that means I have 180 degrees to go from here to here. And I have 180 degrees to go from here to here. I really don't need anything on this side because all of my other information is over here. I'm going to go ahead and label this side, however, 180, because I know then this arc here would be 180 as well. I'm keeping it in the pink color so that we have an association with the arc being highlighted in pink and the 180 being in pink. The 180 also represents the purple section since they are congruent. Now, we might be able to say, okay, well, and even some of you may have done this and it wouldn't be the right way to do it, but let's talk about it. This right here, this intersection of the lines does not happen at the center, so it's not a central angle, so this is not equal to 102 degrees. It's also not an inscribed angle, and I'm saying both of these words, you've got the definition now at the bottom. An inscribed angle would have to have the vertex somewhere on the circumference. So those aren't going to help us. We have to consider some other things here. Go all the way back to topic 1. One of the very first theorem we learned in this class is the vertical angles theorem. And that theorem says if two lines intersect, they create a set of opposite congruent angles. There are two sets of them, right? And what all that's going to tell us then is that angle 1 is congruent to what we're going to go ahead and label angle 2. Now you might be thinking, if we're going through the idea of proofs, Mr. Fimble, you can't add anything. All I'm doing is taking a piece of information that I was given, that those two lines intersect, and I'm labeling them for the sake of clarity and discussing this as we proceed. So I'm not adding information, I'm adding a visual aid or something, a reference point that we can talk about. Now all year I've been doing my little hand flap thing, and I haven't let it go because it's everywhere. Whatever angle 1 is, it's going to open up the same for angle 2 since they're congruent. And that means their intercepted arcs are congruent. This is a huge help here because I know that this entire side is 180. And I've already taken out 102 degrees here. So I'm going to subtract that just so I know what I have left. This is going to be 78 degrees left. Now, since these are equal, they have to share the remainder of this arc with each other. So I'm just going to divide that by 2. I'm going to get 39 degrees. And that is the measure of angle 1. If I wanted to check that, I would say 39 goes here. 102 is already given. 39 is here. 102 plus 39 plus 39 plus 180 must equal 360 for this to work. This is, again, back to 78. These two together are 180. Bring down the 180 I haven't used. And I have 180 plus 180 equals 360. I'm not going to do the last step. We know that's true. And that's how we do number 17. All right, for this one, it wants to know what is the measure of angle 1. And to do that, I'm going to do A minus B. divided by 2 is equal to C. So A minus B over 2 is equal to C. And I'm just going to plug and chug. I'm going to have 94 minus 48 over 2 is equal to C. Let's bring up the calculator. 94 minus 48 is 46. I already divided by, no, I didn't, 2. This is going to be 23 is equal to C. And we get that. All right. You're going to see a question like this on your test, but it's not on your review, and it wouldn't be fair to test you without showing it to you on your review, even though it was in the homework, and most of my classes did ask me to talk about this. So let's do this one. It's going to take a little bit of explaining just to get the idea down, but once I show you one, we can assume that's going to work for the other two triangles, and we can go on from there. All right. So the first thing we want to do is let's look at the fact that QA meets YX at 90 degrees, YZ meets QB at 90 degrees, and XZ meets QC at 90 degrees. On its own, maybe not the most meaningful thing, but we know that BQ is congruent to AQ, which is congruent to CQ, because they are radii of the same circle. So I'm going to go ahead and mark that. Then we have to consider this. If I draw, let's see here. This to this, this to this, and this to this, we have a special thing we learned in topic 5. We have the center here. Is that greatly meaningful to us right now? No, we're not actually going to use it. Just want to bring it to your attention. What I do want to bring to your attention is QZ in both triangle BQZ and in triangle CQZ is going to be congruent every time, as well as here. QY is congruent to QY in both BQY as well as AQY. So I'm going to make sure that we know those are congruent. Now I know I'm just writing congruency marks and they're not actually showing, but what I'm saying is here I have A, here I have Q, here I have X, and here I've marked that 4 times. That's because I can also look at this as this is Q again, this is going to be X again, and this is going to be C. So what I'm saying is if I separate those two triangles, QX is always going to be congruent to QX. And that's good to know because this line, or sorry, this angle is going to be 90 degrees, this angle is going to be 90 degrees. This is the hypotenuse of both of these triangles. So we have, well, what we're going to ask ourselves is, can we show they're congruent? And we're going to ask ourselves the 3 questions for hypotenuse-like congruency. Are both right triangles? Yes. We know that right here and right here. Are their hypotenuses congruent? Well, this corner points at the hypotenuse, this corner points at the hypotenuse. By the reflexive property supported in this diagram right here, they are in fact congruent. Let's go ahead and put this in here, make it even easier to see. So then that's a yes. And then our third question is, do we have a pair of corresponding legs that are, is there a pair of corresponding congruent legs? And the answer to that is yes. And that's right here for the radii that we have. So now we know these two triangles are congruent by the hypotenuse leg theorem. What does that mean for us? Well, since they are congruent by the hypotenuse leg, looks like a WL. Let's fix that. We can say the corresponding parts of congruent triangles are congruent, or as I say, cool people can't teach calculus, or cool people can teach calculus, whichever way you want to look at it. So you want to put your teacher down or not. I always say can't, and that's why I teach geometry. Or can, so that's why I teach geometry. Anyways, since we know the corresponding parts of congruent triangles are congruent, if I were to let's change the colors. If I were to use QX as my axis or my line of symmetry for a reflection, I was going to say axis of rotation since we're about to start topic 11, but you haven't all seen that yet. So if I reflect this over, A is going to map onto C, and we already shown that these are both right angles, so that's a really good sign. QX maps onto QX, again, by the reflexive property, shown in more detail here if we were to separate them. But the most meaningful thing here is that 5 is going to map on to CX, and I have 5. Now, I can already see the same diagram if I rotate each of these. They're not congruent, but I can see that all of these other criteria that I've shown are going to hold true. So what I will do then is say, if I were to reflect this to here, I would have 7. And if I were to reflect this to here, it would be 6. So to find the perimeter, it's going to be 6 plus 5 plus 5 plus 7 plus 7 to get the perimeter. The way I like to think about it is simply this, though. 2 times 5 plus 2 times 6 plus 2 times 7. You're going to get the same answer. I just didn't want to show it the way that I prefer. Because you guys have learned forever that the perimeter is just adding up all the sides. It's doing the same thing, but that would be your answer for this one. All right, last one for this review. This says, given that line YZ is tangent to the circle with center J at point Y, and the measure of WYZ, so start at W, go to Y, go to Z, this guy right here, is 104 degrees. What is the measure of arc WXY? So let's highlight that in a different color. So start at W, go to X, go to Y. So our goal then is to find that measure. So there's two ways I can do it, and I'm going to go I'll go the way that I would assume most of us naturally gravitate towards originally. Here I know that ZY, measure of angle ZY, is 180 degrees because it's a straight angle. So I could subtract this 104 from it, and I'd be left with 76, meaning that this angle here is 76. And I know to go from inside the circle, right where the angle is, out to this, it's going to be 76 times 2 for a total of 152. Now, I of course want to be careful or safe and say that I've done this correctly. So the way I'm going to check it, let's do the green. Let's do this blue. I haven't used this one yet. Now I put checking work in blue here. That doesn't necessarily mean it's always going to be the way you check your work, because this could also be the way you've done it, and then what I've done on the screen already would be you're checking your work. This is 104 degrees. That means if I double it, I get the measure of this arc from here to here. So 104 times 2 is 208. And then I can subtract 208 from 360 to find this purple arc. This leaves me with 152, which I have here already. And I know if I want to go from outside in, I divide by 2, and that's going to be 76. So I got using the linear pairs theorem, I found that WY, and then we don't actually have a point here, so let's just call it alpha. So the measure of angle WY alpha is 76, and I found that two ways. The first time I found it by the linear pairs theorem, which we've been using all year. This is a topic 1 theorem. And then what I did is I used my topic 10 material and concepts to work all of this all the way back around to show again that this angle both times would have to be 76 degrees, so I could feel really confident about the way I answer this question.